In this video, we're going to talk about molecular compounds. The force that holds two atoms together in a compound is called a chemical bond. We have different types of chemical bonds, and a covalent bond is the result of two atoms sharing electrons. So an ionic bond is the result of atoms transferring electrons and being charged, and those two charges hold the bond together. In a covalent bond, the atoms are actually sharing electrons. So a compound with a covalent bond is called a molecule. Let's go ahead and look at naming molecular compounds. Now, something you have to be aware of is molecules, covalent compounds, molecular compounds, those are all used interchangeably. So don't get confused about that. All right, so covalent compounds can also be referred to as molecular compounds, which can also be referred to as just a molecule. So a molecule is when atoms are sharing electrons. The big thing about molecules is they do not have fixed formulas. Ionic compounds have fixed formulas. Covalent compounds do not. So what that means is you must identify how many of each atom are in the compound. So we must identify how many of each atom are in the compound. All right, I could also say we have to identify how many of each atom are in the molecule. So what we have to do is we use the Greek prefixes to identify how many of each atom are in the molecule. We need to use the Greek prefixes to identify how many of each atom are in the molecule. My expectation is that you know the Greek prefixes for numbers 1 through 10. So let's go ahead and make a table here showing that. We'll do the first five. So we have the number and we have the Greek prefix. So one is mono. And the thing about mono, it is not really used. So rarely you have to identify if there is one. If you say the atom's name, then it is assumed there is one. Two is di, three is tri, four is tetra, and five is penta. So let's make another table over here with 6 through 10. 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, nona, not no no, and then 10 is deca. So, like I said, you must know these. You need to know what they are and how to spell them. For 1 through 10. Now, when you are naming covalent compounds, you are going to write the first element name, and then you're going to add the second element name. But in the second element, you're going to add the suffix "ide." So we drop the suffix and add "ide." Very similar to what we did in the naming of anions. Now, if you have more than one of that element, then you need to put the Greek prefix in front of the element name. So if you have more than one of your first element, you do the Greek prefix and then the first element. If you have more than one of the second element, then you have to use the Greek prefix there as well. So with CO2, this is a really good example where mono is not used. I have one carbon, so I'm just going to write carbon. I have two oxygen, so oxygen, the YGEN is the suffix, and I'm going to drop that and add "ide," so it's going to be oxide. I have two of these, so the Greek prefix for two is di, which means that I need to add the di in front of my second element name. So this is carbon dioxide. When you're taking a name and getting the formula, in my opinion, it's a lot easier than an ionic compound because the compound name tells you exactly how many of each atom are in the formula. So I don't see a mono, but I do see the word carbon. So I'm going to put a carbon. Now I see tetra, which I know means four, and I'm dealing with chlorine. So this molecular formula is going to be CCl4. In my next example, I have nitrogen and oxygen. I only have one oxygen, but I have two nitrogen. So I'm going to put di in front of nitrogen, and then I can just put oxide, dinitrogen oxide. Phosphorus pentachloride. I only have one phosphorus, so I'll write my P, but I can see my Greek prefix is penta, and penta means five. So I'm going to write PCl5. Now, this is a compound, so these two need to be next to each other. Don't put a space in between them. PBr3, I only have one phosphorus, so I'm going to just write phosphorus. But now I have three bromine atoms. The Greek prefix for three is tri. I'm going to drop the suffix of bromine and add "ide," so we have phosphorus tribromide. In this next example, I have Greek prefixes in front of both of my atoms. So that means I need to have subscripts for both of my atoms. I'm dealing with carbon and hydrogen. I have two carbon and I have six hydrogen. So I will write C2H6. Notice with covalent compounds or molecules, I do not have to simplify this at all. And I don't want to because that's going to change the identity of the molecule. With ionic compounds, they're all the simplest form because they have fixed formulas. Molecular compounds do not, so you never want to simplify them. Just a quick note about nomenclature of molecules. Organic compounds have their own special set of rules, which we do not cover in this class. So my expectation is that you name all molecules in the way that we have learned in this class. Diatomic molecules, or diatomic elements rather, are named with the element names. So things like O2, Cl2, H2, those are all just their element name. So O2 would be oxygen.